Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss about a very important topic in probability and statistics. It is problems on binomial distribution. Previously, we have discussed about Poisson distribution, and this we have very much discussed about binomial distribution also. So in this binomial distribution, first of all, we give some function, density function for a random variable. So especially for discrete random variable, we define this binomial distribution. So whenever this binomial distribution, we know the Poisson distribution is a limiting case of binomial distribution. So like that, whenever this binomial distribution is taken for infinite value, then it goes for, it becomes a normal distribution. That normal distribution is a special case of continuous random variable. That's why, suppose already previously we have discussed about binomial distribution for two variables, some number of successes P and number of failures Q. Then we know the binomial distribution formula P plus Q to the power N is equal to NC0 P to the power N into Q power 0 plus NC1 P to the power N minus 1 into Q to the power 1 plus NC2 P to the power N minus 2 into Q square plus etc. Rth term NCR P to the power N minus R into Q to the power R plus etc. NCN Q to the power N. This is the actual binomial function, binomial expansion. Some x plus y whole to the power n. Like that, instead of x and y, we are replacing with p and q. P plus q to the power n can be written, can be expanded like this. So now we are going to discuss about how this binomial distribution will be there, and how to find binomial distribution. See, we for that we have to know some fundamental facts about binomial distribution. We know if P stands for number of successes and Q stands for number of failures, then the C, the maximum probability, the sum of all probabilities should become 1. It is evident, already known to us. And next one, the maximum, this total probability for n trials of successes will become p to the power n. Same like that, the number of the total probability of failures in n trials will become 1 minus p to the power n, or 1 minus p is nothing but q, number of failures, q to the power n. Like that, we can discuss about at most, at least, like such type of quantities also. We are going to discuss about how to find the probabilities using our previous data. So this binomial distribution, it gives outcomes, they will become either successes or failures, and the experiments are called binomial experiments or Bernoulli trials. So the experiment of tossing a coin and getting a head is a Bernoulli trial. So thus, in a probability distribution, binomial distribution denotes the success of a random variable x in an n trials binomial experiment. So let us see some conditions to find binomial distribution. Here, first condition is n is finite and defined. N is finite and it is well defined. Second condition is each trial has only two possible outcomes, success and failure. Second condition. Now let us come to third condition. The result of each trial is independent of other trials. One is not dependent on others. They are independent. So the result of each trial is independent of other trials. Fourth condition is the probability of success and failure remains the same in each trial. Suppose when if you flip a coin, the probability of getting head 50%, 0.5, 1 by 2. The probability of getting tail, it is also 50%, it is 0.5 or 1 by 2. Same. So, like that, the probability of success and failure remains the same in each trial. Now, let us see. In a binomial distribution, already we have at the start of the topic, I have introduced the formula how to find probability for binomial distribution. Let P of x is equal to r, x is equal to some random variable or some small r is equal to NCR P to the power r into Q to the power n minus r. As we have discussed for formula of P plus Q to the power n. See, there we have discussed about P plus Q to the power n is equal to NC1 P to the power n plus NC0 P to the power n plus NC1 P power n minus 1 into Q to the power 1 plus NC2 P square into P to the power n minus 2 into Q square plus etc. General term NCR P to the power r into Q to the power n minus and Q to the power n minus r plus etc. Last term NCN Q to the power n. Same this expansion previously we have learnt from 10th class level, intermediate level and degree level. Same that formula is we are representing here as P of x is equal to r is equal to NCR P to the power r into Q to the power n minus r. Generally, it depicts the general term. If we give r is equal to 0, 1, 2, 3, 4, then this expansion comes. So, as P of x is the term of the binomial expansion, that is what we are discussing here. This is the general term of P plus Q to the power n. It is, now let us see Bernoulli theorem or Bernoulli distribution. When do we say it is Bernoulli trial? When n becomes 1, only single trial is there, then we say it is Bernoulli trial. Let there be n binomial experiment trials and let the random variable x denote the success of these trials. If p is the probability of success and 1 minus p, it is nothing but q, is the probability of failure in each trial, then we have the formula P of x is equal to NCR into P to the power r into Q to the power n minus r. So it is nothing but rth term of the binomial expansion P plus Q to the power n. See, all these facts are already as a part of introduction I have discussed there. Sum of all probabilities in the distribution sums up to 1. probability of success in all n trials is p to the power n. Like that, probability of failure in all n trials is 1 minus p to the power n or q to the power n, since 1 minus p is equal to q. Like that, probability of success in at least one trial, at least means minimum that number should be there. Beyond that, more than that, other numbers will also will come. Here, at least one trial means what? P of x greater than or equal to 1 we have to find. So, P of x greater than or equal to 1, it is nothing but 1 minus P of x is equal to 0. So, from total, here P of x greater than 1 is there. So, P of x is equal to 0, you subtract it from 1. It is nothing but P of x greater than or equal to 1. So, P of x greater than or equal to 1 is nothing but 1 minus P of x is equal to 0. That is equal to 1 minus P of x is equal to 0 is what? Q to the power n. So, probability of success in at least one trial is equal to 1 minus q to the power n. 1 minus q power n. Next, like that, probability of at least r successes, at least means what? Minimum up to that number is there, more than that also will be there. So that is nothing, in our language it is P of x greater than or equal to r. So it is nothing but sigma k nck p to the power k into q to the power n minus k, where k runs from r plus 1, r plus 2, etc. up to n. Same like that, probability of at most means it is the maximum. So up to that and below that only will come. That is called at most. So at most r successes is equal to P of x less than or equal to r. So here sigma nck p to the power k into q to the power n minus k, where k runs from 0, 1, 2, 3, 4 up to r. That is the difference between the previous one and this one. If in n trials the experiment is repeated n times, the expected frequencies are n into p of r, for r is equal to 0, 1, 2, 3, etc. So now let us do some very important sums, some interesting sums on binomial distribution. Here as a part of that, let us see in first question what they are asking. Find the binomial distribution of getting a 6 in 3 tosses of an unbiased dice. So that unbiased dice, they are trailing in 3 times. So n is equal to 3. It is clear. Now, what is the problem? Suppose when it in a trial of rolling a die, what is the probability to come for 6? It come one time only. Maximum possible events are 6. So it is 1 by 6. Since the probability for coming 6 is 1 by 6. So here let x be the random variable of getting 6. Then x can be 0, 1, 2, 3. Because why? 4 trials are there. So these are the possible numbers 0, 1, 2, 3 for x. And here n is equal to 3 trials are there. N is equal to 3. Next, what is the probability of getting 6 in toss 1 by 6? We discussed now. So that 1 by 6 is the value of p. So what is the q? Probability of getting not a 6 is 1 minus P means 1 minus 1 by 6. It is 5 by 6. So Q value is 5 by 6. So here P is equal to 1 by 6. Q is equal to 5 by 6. N is equal to 3. X is equal to 0, 1, 2, 3 by 4 trials. So now let us find one by one. Till now we brought the necessary information from the given sum. Now use this in our sum now. Apply in our sum now. Now what they are asking, P of x is equal to 0, x is equal to 1. All these things we need now. That's why now let us find P of x is equal to 0. Means apply our formula. NCR P to the power R into Q to the power N minus R. Apply in that formula. So N value 3, C 0, P 1 by 6 to the power R means 0 here, Q 5 by 6 to the power N minus R means 3 minus 0. So after simplification, it comes as 125 by 216. Next, let us find in the same way P of x is equal to 1. Apply in that formula NCR P to the power R into Q to the power N minus R. What is N value? 3. 3C1 P 1 by 6 to the power R 1. Q 5 by 6 to the power N minus R 3 minus 1 is 2. Simplify, its value will become 25 by 72. Now let us find P of x is equal to in the same way. Keep it in that formula NCR P to the power R into Q to the power N minus R. So N value 3, C, R value 2, 3C2 into P to the power. P is 1 by 6 power R 2 here into Q 5 by 6 to the power N minus R means 3 minus 2. After simplification, it comes as 5 by 72. So P of same like that in the same way, you go for P of x is equal to 3. Why? Here x is taking the values 0, 1, 2, 3. Now we are calculating for P of x is equal to 3. Same in that formula, keep it there, NCR P to the power R into Q to the power N minus R. Then it will become 3C3 into 1 by 6 whole cube into 5 by 6 whole cube. N minus R, 3 minus 3 is 0. So its value will become 1 by 216. All these values keep in one table. It will become distribution. Here they are asking binomial distribution. Binomial distribution means for x is equal to 0, how much is coming? Probability. For x is equal to 1, how much is coming? X is equal to what is its probability? For x is equal to 3, what is its probability? All those things show it in a tabular form. It is only binomial distribution. So here see, we kept in this tabular form. For x is equal to 0, its probability P of x is 125 by 216. We found and we are keeping in this table. For x is equal to 1, what we found? 25 by 72. For x is equal to 5 by 72. For x is equal to 3, just now we found 1 by 216. Show like this, it is only binomial distribution. There ends the problem. Next, let us see one more sum. Find the probability distribution of the number of doublets. Doublets means same to same has to come. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Like that they are called doublets. Find the probability distribution of the number of doublets in 4 throws. Here throws are 4 means small n. Number of trials is 4 of a pair of dice. Now let us find one by one. Here 2 dice are rolling down there. That's why 6 by 6 means 6 into 6, 36 total possible outcomes will be there. Here, total possible outcomes will be 6 by 6, 6 into 6, 36 outcomes will be there. So, there are 36 total possible outcomes for a throw of dice, for which the following outcomes are the success of the experiment. They are asking doublets. What are the doublets? 1, 1, 2, 2. Means first shows 1, first die shows 1, second die also shows 1. Same like that. First die shows 2, second die also shows 2. Same like that. First die shows 3, second die shows 3. Same like that. 4, 4, 5, 5, 6, 6. Now, probability of getting doublets is our success point here. So, P is equal to probability of getting doublets. So, out of 36, how many are there? Doublets 1, 2, 3, 4, 5, 6 are there. So, 6 by favorable events by the total number of events. So, 6 by 36. It is 1 by 6. So, P is equal to 1 by 6 here. So, Q is equal to 1 minus P. It is 1 minus 1 by 6. It is 5 by 6. So, probability not getting 6 is 5 by 6. X is number of doublets. Yeah. So, X is equal to C. How many throws are there? 4 throws are there. So, 0, 1, 2, 3, 4 we have to take. Same like that. You using that formula and using this information, let us find all these values. Here n is what is the information? N is equal to 4, x is equal to 0, 1, 2, 3, 4. P value is 1 by 6. Q value is 5 by 6. Now whatever is needed, we brought it down. Now keep it in our formula and find their values one by one. Now let same earlier in first sum how we found P of x is equal to 0, P of x is equal to 1. Same like that here also using that same formula NCR P to the power R into Q to the power n minus R. Same using that formula using these values relevantly there and find one by one. Now P of x is equal to 0. NCR into P to the power R into Q to the power n minus R. Keep all these values, whatever we found here, keep all these values here. We are finding P of x is equal to 0 is 625 by 100, 1296. Same find P of x is equal to 1. It is becoming 125 by 324. Same find P of x is equal to 2. It is 25 by 216. Find P of x is equal to 3. 20 by 1296. Like that you find the value for x is equal to 4. It is 1 by 1296. Now keep all these values in tabular form. It will become binomial distribution. So for x is equal to 0, we found its probability P of x is equal to 0 is P of 0 is 625 by 1296. So P of 1 is 125 by 324. So P of 2 is 25 by 216. So P of 3 is 20 by 1296. So P of 4 is 1 by 1296. There ends the sum. So distribution means we have to show like this in tabular form. This is a binomial distribution for this given data, for this given sum. Same like that, let us see one more sum. Find the probability of getting at least 5 times head on tossing an unbiased coin for 6 times by using the binomial distribution. Here let us analyze data whatever given in the sum. P of getting an head in a single toss, it is known to us 50% 1 by 2. Same like that Q. P of not getting an head in a single toss. 1 by 2. Same. X successfully getting a head. So here what is the successfully getting head? At least 5 times. That's why we have to find P of X greater than or equal to 5. We have to find P of X greater than at least 5. At least 5 means 5 should be there. 6, 7, 8, 9 also will come. So at least means that number should be there, and beyond that also we have to go. So P of X greater than or equal to 5 is equal to P of getting at least 5 heads. Means what will they come? P of X is equal to 5 plus P of X is equal to 6. That's all only. P of X is equal to 7 is not there. P of X is equal to 5. P of here P of X greater than or equal to 5 means 2 cases will come. 2 are only possible here. P of X is equal to 5 and last case is P of X is equal to 6. Both you can keep it in formula and find it out. P of X is equal to 5 means here now number of trials are 6. That's why n value is 6. Here n is equal to 6. P is equal to 1 by 2. Q is equal to 1 by 2. So keep the values. P of X greater than or equal to 5 we want. So P of X is equal to 5. If we keep it in formula, it will become 6C5 into 1 by 2 to the power P means 5 into 1 by 2 to the power P minus Q means 6 minus P minus R, N minus R means 6 minus 5. Same like that, apply for P of X is equal to 6. It will become 6C6. P means 1 by 2 to the power 6 into Q 1 by 2 to the power N minus R into 6 minus 6. So after simplification, their sum will become 7 by 24. It gives the probability for at least 5 times. Probability of at least 5 times means P of X greater than or equal to 5. P of X greater than or equal to 5 is 7 by 24. Hence the probability of getting at least 5 heads is 7 by 24. In the same way, let us see this question. There are 4 fused bulbs in a lot of 10 good bulbs. So out of 10 good bulbs, 4 are fused bulbs are found. If 3 bulbs are drawn at random with replacement means what? Suppose in that they are taking one, and so suppose that bulb he doesn't like, he is keeping there, and they're taking another one. See, replacement is there, and find the probability of distribution of the number of fused bulbs drawn. So here we have to keep it in mind. It will be varied for replacement and non-replacement. For replacement, one type of probability will come. For non-replacement, other type of probability will come. Both are not same. See, here this problem is nothing but a binomial distribution, as the event of drawing a fused bulb is independent, because only selected number of bulbs are there, so they are independent. Here what is P of drawing a fused bulb is possible bulbs by total number of bulbs, 4 by 10 plus 4. Why we are writing 10 plus 4? Replacement. It is very, very important. That's why I told you replacement and no replacement. For replacement, we have to do in one way. In no replacement, we should not add. That is the difference. So here a replacement case is there. That's why the total number of bulbs will become 10, and again this 4 we have to add. So 4 by 14 it is 2 by 7. So suppose if it is a case of no replacement, then here p value will become 4 by 10 only. So that difference is there. Next, Q is P of drawing a bulb which is not fused. It is 1 minus P. 1 minus 2 by 7. It is 5 by 7. Next, X, event of drawing a fused bulb. That is the event here. Now X can take up the values. 4 bulbs are there. That's why 0, 1, 2, 3. These are the possible values of X. So now using this data, keep it in our formula and simplify. Find P of X is equal to 0. Means what? P of getting 0 fused bulbs in all draws. Keep it in formula. NCR, P to the power R into Q to the power N minus R. N value 3, 3C 0. P is 2 by 7 to the power R 0. Q 5 by 7 to the power N minus R 3 minus 0. After simplification, it is coming as 125 by 343. Now find X is equal to 1. P of X is equal to 1 means what? Probability of getting one time fused bulb. Keep it in formula. NCR into P to the power R into Q to the power N minus R. 3C1 into 2 by 7 to the power 1 into 5 by 7 to the power 3 minus 1. Its value is coming as 150 by 343. Now same like that, find P of X is equal to 2. P of getting 2 times means two fused bulbs we are taking now. So keeping in formula, we find P of X is equal to as 60 by 343. Now find P of X is equal to 3. Same like that, it is coming as 8 by 343. Now keep all these values in tabular form. It will become distribution, binomial distribution. So for this given sum, X is taking 0, 1, 2, 3 values. So probability of 0 is 125 by 343. Probability of 1 is 150 by 343. Probability of 2 is 60 by 343. Probability of 3 is 8 by 343 for this sum. Same like that, let us see one more interesting sum. On average, every 1 out of 10 telephones is found busy. Out of 10, one phone is found busy. So on average, every 1 out of 10 telephones is found busy is given here. 6 telephone numbers are selected at random. Here, X is the event of getting a busy phone number. P is a probability of getting a phone number. It is out of 10, 1 is busy, so 1 by 10. It is our P. So Q will become 1 minus P, means 1 minus 1 by 10, it is 9 by 10. So here total number of telephones are 10. So probability of getting one telephone busy is 1 by 10. So not busy is 1 minus 1 by 10. It will become 9 by 10. So X is the event of getting a busy phone number. Now what they are asking, find the probability that 4 of them will be busy. Means what we have to find? P of X is equal to 4 we have to find. P of X is equal to 4 we have to find. So keep it in our sum, in our formula. NCR means 6C4. P to the power P is 1 by 10 to the power R. What is R here? 4 into Q to the power means 9 by 10 to the power N minus R means 6 minus 4. So after simplification, it comes as 0.001215. So like that we can find the probability for required quantity. Same, let us see one more important sum. An unbiased dice is thrown until 3 6s are obtained. So up to 3 6s come, he has to proceed that trial. So this unbiased dice is thrown until 3 6s are obtained. Find the probability of obtaining the third 6 in the 6th throw. Here specifically they are asking, we have to find the probability of obtaining the third 6 in the 6th throw. So here let us analyze the data. Since each throw is independent of the previous throws, we can apply the binomial distribution formula to find the probability. Here what is success probability P? P of getting a 6 in a throw. It is 1 by 6 we know. So what is Q? P of not getting a 6 in a throw. It is 1 minus P, means 1 minus 1 by 6, it is 5 by 6. So according to the question, 2 6s are already obtained in the previous throws. See, they have, it is given in the first sentence only. An unbiased dice is thrown until 3 6s are obtained. That's why already 2 6s are already obtained. According to the question, 2 6s are already obtained in the previous throws. Therefore, required probability is what? Probability getting exactly 2 6s in 5 throws, total 6 throws. So, in the third 6, when does it come? P of getting exactly 2 6s in 5 throws into P of getting a 6 in the 6th throw. So, this is a chain rule in probability. In chain rule in probability, they already among n trials, n minus 1 trials are already over and succeeded. Then for that remaining last throw or last trial, this chain rule we have to use. P required probability is equal to P of getting exactly 2 6s in 5 throws into P of getting a 6 in the 6th throw. This is probability getting exactly 2 6s in 5 throws is what? 5C2 into P square into Q cube. And what is P of getting a 6 in the 6th throw? 1C1 P to the power 1 into Q to the power 1 minus 1. So after simplification, it comes as 625 by 23,328. Now let us see one more question. The probability of a boy guessing a correct answer is 1/4. How many questions must he answer so that the probability of guessing the correct answer at least once is greater than 2/3? Here, try to understand the question properly. Here, probability of guessing a correct answer is 1/4 given there. Now, what is Q? P of not guessing a correct answer. So, 1 minus 1/4 is 3/4. Here, Q is 1 minus P, it is 1 minus 3 by 4, 1 minus 1 by 4, it is 3 by 4. Let him answer n number of questions. Then, here what they are asking, how many questions must he answer so that the probability of guessing the correct answer at least once. At least once means one time he has to answer correctly. 2 times, 3 times, 4 times also will come. So minimum one time should be there. At least one time he has to answer it correctly. After that he can go for other 2, 3, 4 other numbers also. Then what we have to find here in our terminology, P of x greater than or equal to 1 we have to find. P of x greater than or equal to 1 we have to find now. See, it is nothing but what? P of guessing at least one correct answer out of n questions. That is what we have to find. So it is equal to 1 minus P of number of successes. Already I told you 1 minus P of number of successes is what? Q to the power n. Number of failures. Here number of failures we have to write. 1 minus q to the power n. So, given 1 minus q to the power n is greater than 2/3. It is given there. So, 1 minus 3 by 4, cube is 3 by 4 to the power n should be greater than 2/3. So, 1 minus 3 by 4 to the power n should be greater than 2/3 because of this. Then what happens? 3 by 4 to the power n is less than 1/3. Now discuss. Now let us check the above inequality for different values of n is equal to 1, 2, 3, 4, etc. If you keep n is equal to 1, it's not true. If it is n is equal to false, n is equal to 3, false. For n is equal to 4 only it is true. Thus, you must answer at least 4 questions. Very, very important question. By analysis, we have to do. One equality will come. That equality we have to analyze for giving values for n, 1, 2, 3, 4, etc. For n is equal to 1, fails. N is equal to 2, fails. N is equal to 3, fails. For n is equal to 4, that inequality holds good. Means, you must answer at least 4 questions. Excellent question. Now let us see. When a biased coin is tossed, the probability of getting a head 3 times more than the probability of getting a tail. This is the constraint. The probability of getting a head 3 times more than the probability of getting a tail. Now let us see. Find the probability distribution for getting a tail. The coin is tossed twice. 2 times it is tossed there. Now analyze now. Let the probability of getting a tail be. Then the probability of getting a head will be 3 times their telling. 3 into P. Now, sum of the probability should become 1. So, P plus 3P is equal to 1. 4P is equal to 1 means P is equal to 1 by 4. So, Q is equal to 1 minus P means 1 minus 1 by 4 is 3 by 4. Like that, here P is becoming 1 by 4. Q is becoming 3 by 4. X is event of getting a tail in a toss. Then, possible values of x will be 0, 1, 2. You find P of x is equal to 0. Keep in that formula answer x power P power r into q to the power n minus r. It is coming 9 by 16. Find P of x is equal to 1. It is 3 by 8. Find P of x is equal to 2. 1 by 16. Keep all these in one tabular form. it will become binomial distribution. Probability of binomial distribution. So for this sum, for x is equal to 0, its probability P of 0 is 9 by 16. If x is equal to 1, probability of x is equal to 1 is 3 by 8. If x is equal to, probability of x is equal to, P of x is equal to is 1 by 16. This is the binomial distribution for this given sum. Now let us see sum. A bag contains 5 green balls. We have to write here. Green balls are 5 and 3 red balls. Red balls are 3. If 2 balls are drawn from the bag randomly with replacement, very very important. Previously I have explained about this. Replacement is different from non-replacement. Both cases are different. Here replacement case is given. Bag randomly with replacement, find the probability distribution of the number of green balls drawn. See, first let us analyze the matter. Here what is P? Means P of getting a green ball. Means total green balls are 5 in number divided by total number of balls. 5 plus 3, 8 balls are there. So it is 5 by 8. So Q is equal to 1 minus P. It is nothing but P of not getting a green ball. So it is 1 minus P means 1 minus 5 by 8 means 3 by 8. It is Q value. So here P value is 5 by 8. Q value is 3 by 8. X is what? Event of drawing the green ball. Then the value of X could be 0, 1, 2. Why? See, my trials are 3. That's why the X can take the values 0, 1, 2. Now find one by one. P of X is equal to 0, you find. All the values are given here. Probability of getting P of X is equal to 0 means what? Here probability of getting no green ball means 2C0 P to the power 0 into Q to the power 2 minus 0. It is 9 by 64. Next, find P of X is equal to 1 means what? Probability of getting one green ball. It is in our formula 2C1 P to the power 1 into Q to the power n minus r into 2 minus 1. It is 15 by 32. Like that you find P of X is equal to 2. What is P of X is equal to? Probability of getting 2 green balls. It is 2C2 into P square into Q to the power 2 minus 2. It is 25 by 64. So like that, we can analyze binomial distribution randomly in so many ways. So when do we say it is a distribution? Distribution means for different values of the variable, what probability that we are getting, and showing those for those values, those concerning probabilities in one tabular form, then it becomes distribution, binomial distribution. So like this elaborately we can discuss about binomial distribution. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.